So we are, and you can talk. I mean, you know, it's like it's a regular class. They can hear you, you know. So, I want to go over the test, just some of the key points. But the first thing I am going to say is that I strongly suspect that a little more practice would improve the grades. So if you're not like 100% satisfied with your grade, you need to really ask yourself, how many practice problems did I do? Did I wait until the very end and try and cram it in? Did I come into office hours? You know, so these are the questions that I think you need to ask. Have I talked to you about beer and pizza? Yes? No, you don't remember? Yeah. I'm gonna beer and pizza. Okay. So when I was in college, well, first of all, when I was in college, we would start the semester. You get a syllabus from the professor. You go by your books, and then there would generally be like a midterm and a final, and that was it. You know, so you just kind of had to keep up. If you didn't keep up, you were kind of toast, because you get to the midterm, you get to the final. I mean, I remember walking through my dorm, and these people are like driving themselves crazy studying for their finals, you know, like literally like beating their heads against the wall, and you know, and I'm walking around saying, hey, you want to go get some beer and pizza? Because I kept up, you know, and it just made life so much easier and so much more interesting to kind of keep up. So that's why I have the thing that says, now of course I wasn't 21, but like they wrote on the side, it was root beer. You get it? See, root beer and pizza? Yeah, but it really wasn't. But so, you know, if you're not doing practice problems on an ongoing basis, and you're trying to cram it all in at the end, you're making a mistake, and it's gonna be a struggle. So, you know, 1 or 2 a day should be more than enough, right? Or every other day is even fine. But that is, yeah. And also the last practice problem check that we had also was a little bit disconcerting. It's just kind of like, there's not enough practice going on here. So that's a recommendation. So I'm looking at the, I should probably call up the test so that we could look at it. NDA, Precalc, tests and quizzes, that year, chapter 6, 6.2. Okay, here we go. Okay, so let's look at the whole page. Okay, so the first problem was, now this, you can't read this at all. This is ridiculous. Really, with this problem here and the next problem there, I just want you to really understand how this 30, 60, 90 right triangle works, because that's where we get the values for the special points on the unit circle. So if I want to find out a 30, 60, 90, and I want to find out what the values are, I am told that the hypotenuse is 1. And the way I look at it, I know that this is a 60-degree angle, this is a 30-degree angle, this is a 90-degree angle. And so I kind of go down here and I duplicate the triangle. So now I have a 60, 60, 60, I have an equilateral triangle. And all the sides are 1. That means that this side right here is 1/2 because I duplicated it. And then I just have to use the Pythagorean Theorem to figure out, well, how long is this side? So I have 1/2 squared plus a squared, that's my missing side right here, is equal to 1 squared. So 1/4 plus a squared is equal to 1. A squared is equal to 3/4. That means a is equal to the square root of 3/4, which is the same thing as radical 3/2. So if you see that, and then you look at the unit circle, you see every single pi/6 or pi/3 angle is some form of a 30, 60, 90 right triangle, and they're all going to have sides Sines and cosines are going to be 1/2 and radical 3 over 2. It's just a matter of placing it in the right spot. Similarly, with the next problem. Uh-oh. How do I get rid of the ink? Let's see here. I think I just need to erase it. Okay, there we go. All right. It's a 45-45 right triangle, and again we have the hypotenuse is 1, and if it's 45-45, that means this side is A and this side is B, but A is equal to B. So I can do A squared plus A squared equals 1 squared, or 2A squared equals 1. So A squared equals 1/2, and A equals the square root of 1/2, which is equal to the square root of 1 over the square root of 2, which is 1 over the square root of 2, which if we rationalize it comes out to be the square root of 2 over 2. So that's why every single angle, the red angles on the clock over there, are all pi over 4 angles. They're all 45-degree right triangles, and they all have sines and cosines of radical 2 over 2. So I wanted you to do this because although a lot of people memorize the clock, to me that takes up a lot of brain space, and I like to I don't like taking up a lot of brain space. I got other things I'd rather be thinking about than memorizing a unit circle, right? But if you kind of know how to derive it like this, then the unit circle doesn't require any memorization. It's just you're just able to do it. Does that make any sense? Are we okay with that? Don't all speak at once. Okay. All right. So we got the 45-45 right triangle. Like I said, on the unit circle, actually, so just I actually do want to talk about this a little bit, because the main mistakes I saw on the unit circle were like reversing these numbers. So like this right here is an 11 pi over 6 angle, and the coordinates of that point are radical 3 over 2 comma 1/2, and the 1/2 is negative because I'm in the fourth quadrant. And over here, this is a, see, this would be what, this is a 5 pi over 3. I was thinking 10 pi over 6, and that didn't make any sense to me. This is a 5 pi over 3 angle, and the coordinates are 1/2 negative radical 3 over 2. So people had reversed the coordinates. You with me here? Okay, but again, I want you to think about the triangles here. So if I kind of draw the line right there through my 5 pi over 3 angle, and then I draw my perpendicular up to the x-axis, I can see I have a 30, 60, 90 right triangle, right? And the short side is 1/2, and the long side is radical 3 over 2. So that's got to be my y value, right over here, radical 3 over 2, and this has to be my x value, 1/2. So, okay, so that was the main mistake I saw there, and if you kind of think about those other two, how you derive these angles from the triangles, I think that would help. Then, if I'm going to number 3, wait, I got to erase this stuff. It won't go away by itself. Nope, please go away. Thank you very much. Okay, that's good. Okay, so this is a trigonometric function. The input value is an angle. The output value is a number. That's the same thing here. So I need to find out what is cotangent 3 pi over 2. So I'm looking at my circle. Here is angle 3 pi over 2. The coordinates of that are 0, comma, negative 1. So I know that cotangent theta, or I should say cotangent 3 pi over 2, is equal to cosine 3 pi over 2 divided by sine 3 pi over 2, and I know that from my 6-pack. So this is 0, negative 1. That means this right here is equal to 0. We okay with that? Okay. Then I have to figure out tangent negative 7 pi over 4. Well, if I divide my unit circle up into pi over 4s, and I'm going negative, there's 1, 2, 3, 4, 5, 6, 7. Negative 7 pi over 4, which is coterminal with pi over 4. And the coordinates are going to be radical 2 over 2, comma, radical 2 over 2. Because it's a pi over 4, it's a 45-45 right triangle. Am I still going okay? Okay, so tangent negative 7 pi over 4, so that would be sine negative 7 pi over 4 divided by cosine negative 7 pi over 4, and since it's pi over 4 angle here, it's radical 2 over 2 divided by radical 2 over 2, which is equal to 1. So I'm asking what is 0 plus 1, and that answer is 1. So kind of the key here is to recognize that this is a number and that is a number, and all I'm asking you to do is add together two numbers. Questions? Okay. So we'll erase this. And then we'll take a look. Okay. So with this one, this is not a unit circle problem. Okay. The hypotenuse is not going to be 1, because if I have a side that's 4 and another side that's -3, my hypotenuse is the largest side of a triangle. So it can't be a unit circle. So I'm just going to kind of draw my thing here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I have the point 4, -3. So I am told that my angle lies on that point, or that my terminal side goes through that point. So my angle is really this angle right here, but my reference angle is that one right there. And if I'm looking at my triangle, I'm going to make a triangle out of this. I have one side is 4, one side is -3, because this is the point 4, -3. And I have to figure out how big is my hypotenuse. So 4 squared plus 3, so I can even go -3 squared is equal to h squared. 16 plus 9 is equal to h squared 25 is equal to h squared. My hypotenuse is equal to 5. So now to find my 6 trigonometric functions, it's all just SO, CA, TOA. So sine is going to be y is going to be opposite over hypotenuse, -3 over 5. Cosine, adjacent over hypotenuse, 4 over 5. Tangent, opposite over adjacent, -3 over 4. And then these are just the reciprocals, -5 over 3, 5 over 4, 4 over 3, negative. And that's the answer. Okay. The most common mistake here was to say that, say, for example, sine was equal to -3, because that's the y value, or that cosine was equal to +4. Those can't be the case, because the maximum value of sine or cosine is 1, and the minimum value of sine or cosine is -1. If you ever get an answer to a problem that gives you a sine or a cosine greater than 1 or less than -1, stop and reevaluate, because it can't be the case. Questions? We're okay with that? All right, let's do one more thing here, and then I got to get off of this headset. All right, so the last problem is a plug and chug problem, and I would say the majority of people who tried it got it right. They got 120 seconds, and anybody that got 1.47 seconds, 1.20, 1.4, anybody that got 1.47, it was because you were in radians and not in degrees, and the problem is in degrees. So this was really just kind of a, are you paying attention, calculator check kind of a problem. Yes? Okay, let me out of this thing.